for joining today's session, masterclass by Dr. Ramesh Chandra Srivastava. Today is our second session. I hope everyone had a very wonderful Diwali vacation in the whole last week. And I'm not taking too much time. Uh, I would like to remind everyone about the Best in Class challenge. It's compulsory for all the TiL-AI teachers. We have over 200 teachers in this cohort, and we would request each one of you to share at least one resource or share the link of one resource. We only have, including today, 3 more days left till the end of the competition. So I would request everyone to share at least one resources towards any of the challenging topic that we have identified during our last boot camp. Over to you, Dr. Ramesh Chandra, sir.
Thank you, Khalid. Welcome all of you in the TiL-AI master classes. It's the second session. The last session was postponed due to the Diwali vacation. And the unit 3 and 4th, that is the pair of linear equations in the, I'm audible or not? I'm audible?
Yes, sir, you're audible.
Okay. So the two topics, that is the pair of linear equations in the two variables, as well as the quadratic equation. These two units will be rescheduled in the next month, perhaps. Now today we will take the 2 units, that is the arithmetic progression and the triangles. These are the perhaps the 5th and 6th unit of this 10th grade mathematics of the NCERT. So now one thing is very important, that is first of all, the challenging topics, the identified challenging topics of the arithmetic progression was confusion or mix-up between the nth term and the sum of the n terms of an arithmetic progression. The second was the deciding when to apply the last term formula versus the nth term formula. Then finding the nth term from the end of a sequence. The next one is the understanding and explaining the deviation and reasoning behind AP formulas. Proving results and providing reasoning in AP related questions. And distinguishing between sequence, series, and progression. And the last one is challenging topics of this arithmetic progression is the relating arithmetic progression to real life contexts and examples. Similarly, in the triangles, the application of similarity in solving problems from other topics. The next one is the difference between the congruency and similarity. Correspondence of sides and angles in the similar figures. Identifying triangles to be proved similar. Application of basic proportionality theorem. Application of converse of the basic proportionality theorem. And the last one is deciding when to use basic proportionality theorem or its converse. So these are the some challenging topics but some of them like that in the AP as well as in the triangles, so many challenging identifying topics are there. And I will discuss about all the topics, challenging topics after discussing these topics. So now I'm going to share my PPT. Please wait few seconds. So the screen is visible or not? The
Visible,
screen
sir.
is visible.
Yes, sir.
Yes, sir. Okay. Okay. Thank you. So now, first of all, before going to this topic, arithmetic progression, I will discuss about some mathematical keywords like that a pattern. What is pattern? The pattern has the very important key role in the mathematics. We can develop the problem solving skills as well as we can develop the critical thinking through this approach of the pattern in mathematics. A pattern in mathematics is a regular, repeated, or logical arrangement of numbers, shapes, or objects according to a certain rule or order. So this is the very common definition of the pattern. But before going to that series, sequence, progression, what is the pattern? Like that, we can see the pattern as a number pattern, like it we write it 2, 4, 6, 8, 10. So this is a pattern. In geometrical pattern, formed by shapes, arranged or repeated symmetrically, like triangle having the three sides, squares, pentagon, hexagon. So these are the patterns in the geometrical pattern. And some algebraical pattern, if we write is 1, 4, 9, 16, or 3, 5, 7, 9. So many patterns we can see in our surroundings, the pattern. And we study the pattern, and on the basis of the pattern, we develop some mathematical tools. And one of the tool is we are going to study in this session. That is the arithmetic progression. But before study the arithmetic progression, we should go for the some keywords also, like that what is the sequence? What is the sequence? Before knowing the sequence, before knowing the progression, we should go through that some pattern, and the pattern is in the form of the sequence. There is a difference between the pattern and the sequence. I will illustrate it with some example. A sequence is an ordered list of numbers that follows a certain rules or patterns. Here, the certain rules are patterns. For example, the number of petals in flowers are arranged in increasing order. That is 3, 5, 8, 13. That is Fibonacci pattern. This is very important. In the last session, I discussed about the Fibonacci pattern, and through that the quotient, that golden ratio, that was the very important pattern. That is the Fibonacci. And we can see the Fibonacci pattern in the flowers, in the natures, in different ways. And another pattern is that the days of the week or months of the year. So these are the patterns. Now, sequence as a function, though our textbook in the NCERT, it is not given, but I will try to give you some idea that the sequence can be understood through the function. Sequence is not a function, but we can understand the sequence through the function. And the function is not given in our textbook, but being a teacher, we can understand it very easily. That is in the higher mathematics, in the class of 11th or 12th or in higher mathematics, there is a need of some such type of the functional approach of the sequence. A sequence is a special kind of the function whose domain is the set of natural numbers. This is a very important line. whose domain is the set of natural numbers. This means each term of sequence corresponds to exactly one natural number that indicates its position in order. And it is defined as a function f of n to r. Here, R may be the set of real number, or R may be the set of some objects, but domain must be the set of the natural. The value Fn, what is the value of Fn? That belongs to the codomain. That is, if f of n to r, yeah, f of n to s is defined, then Fn will be the element of the s or r. And Fn gives the nth term of the sequence, usually denoted by a. An is here, the suffix is there, not an. An means that is the serial number of natural, corresponds to the n natural numbers to the object A. And what is the progression? A progression is a special kind of sequence that follows a fixed rule. In sequence, like that in Fibonacci numbers, 3, 5, 8, 13, we cannot give us some standard formula for that sequence. But in the case of progression, there must be some fixed rule, fixed formula to find the some term of the pattern. And what is the arithmetic progression? That is the type of the progression. One of the type of the progression is the AP, that is the arithmetic progression. The each term increases or decreases by a fixed number, like our savings rupees 100 every week, 100, 200, 300, per week 100 rupees. So it increases. Number of chairs in successive rows in auditorium increasing by the 2's time. 2 each time means if we have the 10 chairs in the first row, then the second row 12 chairs, third row 14. So the number of chairs increasing by 2. So this is a pattern. And one thing is very important in arithmetic progression. We can have a common difference between the two consecutive terms, or between it is not necessary that we can take the some number system pattern. We can take it in the geometrical pattern. We can take it in some other patterns in some different objects pattern. But here we are discussing about the only number. That is what is the series? The series is the sum of terms of a sequence. The sum of the terms, if we have the suppose 2, 4, 6, 8, 10 is a progression or sequence, having the some definite formula, then if we sum up all the terms, that is some writers in some reference book, it is given that we can add or subtract. But there is no meaning of subtract. We can only operate the operation, give the operation only the addition. That is, if we have the A, now we will take the some examples in the next slide. So a series, the sum of terms of the sequence, for example, the total amount saved over months when saving 100, 200, 300, 400. Now, for every day's saved savings of the months, then the sum of these savings, then we can say that this is a series. If we have the A1, A2, AN, like that, the terms, and we add these things, these terms A1 plus A2 plus AN, then this is a series. And it may be finite, it may be infinite. And symbolically, Sn is equal to, that is the notation of summation, I varies from 1 to 1 AI. AI is a general term. And when we put I is equal to 1, 2, 3, 4, n, then we can get the A1 plus A2 plus AN. All progressions are sequences, but not all sequences are progression. Because we cannot, it is not necessarily we can develop a general formula for the sequence, but every progression is a sequence. Because we have the pattern, in sequence as well in the progression. But in the case of the progression, we can develop a general formula to find some particular term of the pattern. Now, an AP is a sequence of numbers such that the difference between the consecutive terms is constant, as already discussed. This constant difference is called the common difference, denoted by D. These are some common things which are given in the textbook. Only I am repeating here. The first term is A1RA. The another term is denoted by AN or TN. And the general term of this AP, AN is equal to A plus N minus 1 into T. That is, N is the number of terms and A is the first term, T is the common difference. Now the sum of these are the given in the textbook. That is why I'm not discussing here how we get the formula for the n term of an AP or sum of the n terms of an AP. So these are the very simple, it is given. And that is the sum of the n terms of an AP. That is n by 2, 2a plus n minus 1 into t, or n by 2, the first term plus the last term of an AP. Now, let an AP be A plus T. D is a common difference. A plus 2D, A plus N minus 1D. That is the nth term. And formula for the nth term from the beginning is A plus N minus 1 into T. It is a very important. In your challenging topics, the one challenging topic is there that how can we get the nth term if we start from the end of an AP. So I'm going to give the formula when we start from the end. Now this is the formula when we start from the first term, and now the other term that is the A plus N minus 1 into T. Suppose the total number of terms in AP is capital N, and we need to find the kth term from the end, So here, the kth term from the end is equal to n minus k plus 1 term from the beginning. That is the kth term from the end. If we start from the end, that is when we take the first term from the last term, that is the t n minus k plus 1 put at the place of n minus k plus 1. N minus 1 means n minus k plus 1 minus 1 into t. That is t dash k is equal to a plus n minus k into t. This is the formula of the kth term when we start from the end. This is the topic, your challenging topics. And another approach is there. Because when we start, it is not given in PPT, only I am discussing. If you start from the end, that is the first term is L. If we start from the end, the first term is L. That is the nth term of when you start from the first term beginning. And if we start from the end, then the first term is L. And last but one, the term is L minus T. Similarly, we can develop the formula for the nth term is equal to, that is the L. At the place of A, we can take the L. And at the place of D, we can take the minus T, that is the common difference. When we start from the end, the common difference will be the minus T. So, L minus N minus 1 into T. So, this is the formula, another formula that T dash K is equal to A plus N minus K into T, and the same formula is L minus N minus 1 into T. Now, let us take some example. That is, if we have the arithmetic progression 5, 10, 15, 20, 25, and 30. And if we want to find from the end to the fourth term. So, what is the A? A is equal to, when we start from the first term, that is 5, D is equal to 5, and N is equal to, the total number of term is 6. So T dash 4, if we start from the end, what is A? That is 5. And that is total number of terms is say 6. And K, that is the fourth term from the end. We want to find. That is 6 minus 4. and D is 5. In this way, we get the fourth term from the end is equal to 50. And here it is given that from the end, the fourth term is 50. So we can use this formula. If we start from the end as the first term at the last term, that is the L. And with this formula, we can get the nth term from the last term, that is from if we start from the end. So these are the very simple. And what is the real life applications? The real life application of this AP is some very interesting. That's the fixed salary increment. If someone having the some increment, annual increment, then every year, according to the rule of the increment, so gradually the first year, second year, third year, the increment increases in the arithmetic pattern. That is, if we have an increment in the first year is 1,000, then next year again 1,000, next to next year is again 1,000, like that. Simple interest follows an AP also. Ladder rungs, for a ladder with the sloping sides, the length of the rungs might decrease by a constant amount from the bottom to the top. Now we can see in the ladder that from bottom to the top, gradually the size of the rungs decreases from the some pattern. That is, if we decreases the 10 centimeter, 20 centimeters, gradually every steps we decreases from bottom to top 10 centimeter or 5 centimeter whatsoever. Stadium theater seatings. If we have in the first row 50 chairs, in the second row if we decrease 10, 40, then next row 30, then 20, 10, like that. So now come in the triangles. In the we have the very limited time, so now come on the triangles, and here the similarity is a very important. The triangles, that is a polygon having the three sides, and before the study the similarity, we should know what is the congruency, and here the congruent figures. First of all, what are the congruent figures? The two figures are said to be congruent if they have the same shape and the same size. The shape and size, these two things are very important. That is shape and size. In the congruency of the figure, both must be the same. But in the similar figure, if the figures are the same shape but not necessarily the same size, are called similar figure. This is the main difference between the congruency and the similarity of any figures. That there are two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. These two conditions are very important for the similarities of the any polygon, not only for the triangle, but it is for all the polygons that their corresponding angles are equal and their corresponding sides are in the same ratio. So we will use the two properties of the similarity in the case of the triangle also. So similarity in the triangles. The triangle is also a polygon. So we can state the same conditions for the similarity of the two triangles. That is, their corresponding angles are equal and their corresponding sides are in the same ratio. Here, one thing is a very important I would like to discuss with you. Because before going to the conditions of the similarity, we will discuss about the first condition that their corresponding angles are equal. Suppose if we have the two triangles ABC and DEF, and the angle corresponding means That is the angle A corresponds to D, B corresponds to the E, C corresponds to the F. Here, in this figure, not in all the figures, in the some figures A corresponds to the F, maybe. But here, which are, you see it that A corresponds to D, B corresponds to E, and C corresponds to F. So the corresponding angles are equal. If the corresponding angles are equal, then it may be the congruent as well as it may be the similar from the first condition. In the congruency, the corresponding angles are also equals. But in the second case is very important, then their corresponding sides are in the same ratio. That is, corresponding side means AB and D. So AB by D. Corresponding sides, the ratio AC and here DF, AC by DF. And similarly the BC by EF. If these ratios are equal, then we can say that the triangles or polygon are similar. But in the case of congruency, the ratios are also equal because they have the 1:1:1 equal ratios. So in the case of congruency, the second condition that the sides are the same ratio, that the sides are the only having the ratio same. In the case of congruency also, and the first condition also fulfill in the case of congruency. But what is the difference between the congruency and similarity? Here, every congruent figure is, now let's see its first. In the case of ABC and DEF, here if A is equal to D, angle A is equal to D, B is equal to E, C is equal to F, and the ratios are equal, then we can see this is a similar. But if the angles are equal and the ratios are 1:1:1, each sides are equal, that is AB is equal to DE, AC is equal to DF, BC is equal, then this is a congruent. So we can use this congruency and similarity property of the triangles in our daily life, as we will see in the some examples in this session.
और जो एरिया है ना उसको चिपका देंगे.
So please
ठीक है.
mute your mic. Please mute your mic. And what is the basic proportionality theorem? This is the Thales theorem. We can see that this is the Thales theorem. But here, what is the basic proportionality theorem? It's a very important theorem for to prove the similarity of the triangles. And these two theorems, that is the theorem, basic proportionality theorem, as well as its converse, both are very applicable in our day-to-day life. So how it is useful in our day-to-day life, we will see in the next PPT. Now only here, I want to state the basic proportionality theorem. That is, if a line is drawn parallel to one side, that is D is parallel to BC, and this of a triangle to intersect the other two sides in a distinct point, that is in distinct point, that is D and E. The other two sides are divided in the same ratio. That is, if D is a parallel to BC, then AD ratio DB is equal to AE ratio EC. This is the basic proportionality theorem. And it is a very useful to prove the similarity of the triangles. How? So let's see it in the next PPT. The next slide. And what is the converse of this theorem is? That is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. That is, if AD ratio DB is equal to AE ratio EC, then DE will be parallel to the BC. This is the converse of the basic proportionality theorem. So these two theorems are very important. In short, we say it that is a basic BPT, that is basic proportionality theorem, and the converse of this is. Now, what are the criteria for the similarity of the triangles? So the first condition is that the angle, if the two triangles, in the two triangles, the corresponding angles are equal. like that in the previous slide, the A is equal to angle A is equal to D, angle B is equal to angle E, angle C is equal to angle F. That is A means that is the corresponding angles are equal. The first condition is this. Any one of them, not all the necessary. But the first A, that is if the angle corresponding angles are equal, then the triangles will be the similar. And the second condition is side, side, side. What does it mean? In the congruencies also this condition is there, but here side, side, side means the ratio of the sides. That is, if we have the two triangles ABC and DF, then AB ratio D is equal to AC ratio DF and BC ratio EF. So if the side ratios are equal, then this is in the short form we can write it as S. And the case of the congruency, that is the sides are equal. Here the proportion are equal. And the third one is side angle side. This is side angle side. That is the if in triangle ABC and in triangle DF, AB ratio D is equal to the AC ratio DF and the angle here B is equal to the angle E. So side angle side, if the corresponding sides ratios are equal and the angle between the sides are equal, then the triangle will be the similar. Now come on the application of these similar triangles. This is the main, the important application of this similarity of the triangles. Let's discuss it a very proper way. That is, first is indirect measurement shadow problem. What is this? This is the very important. Finding the height of tall objects. We can find the height of a building, a tree, or a pole by comparing its shadow length to the shadow length of an object of known height like a person or a street. We can correlate the trigonometry with the similarity of the triangles. When we go in the next chapter, that intro, the application of trigonometry, so we can associate with this similarity of the triangles. Here, if we have some tall objects like some building or some pole or some tree, and how can we find without the measurement, proper measurement of the height of the building or tree or pole? So how can we use the property of the similarity of the triangles? This is the very important. So only we have to make the two similar triangles. And with the comparison of the side, with the property of the similar triangles, we can find the one unknown. If we want to find the height of a tall object, then that is the unknown. So with the help of the similarity of the triangles, the two triangles, we can find the unknown height of the objects. How can we use it? So now two things are very important. That is how we can make two similar triangles. That is very important. So through our some constructive approach, if we want to find suppose a building is there, then shadow of the building must be okay. And we can have some known objects like that some known height like a person or a stick whatsoever, and also we can find the shadow of that stick or person. With the help of these two, we can make a two similar triangles, and with that similar triangle, the stick height is known and shadow is also known. The building height is not known, but the shadow is known. So with the help of these two triangles, we can apply the properties of the similar triangles, and in this way, we can find the height of the tall objects. Now, another है measuring river width. It's a very interesting. Suppose we want to find the width of the river without crossing it. We don't have some tool with which we can measure the width of the river. So how we can find the width of the river with the help of with the properties of the similar triangles? It's a very important. So listen it very carefully. A surveyor can set up the two similar right angle triangles. Here the one approach is here the same approach is there, that we have to make the two similar right angle triangles. How can we make it? So I will tell you. One on the bank of a river, by measuring the length of the accessible sides and ensuring the triangles have the equal angles. They can use the proportional relationship of the sides to calculate the unknown width across the river. So if you have some paper and pen, then please draw a figure here in your session. If you have some paper and pen, so make a river having some width d, suppose. And the second, suppose we have I have a survey, and if we have some point A on in this side of the river, and the other side of the river, suppose another point is B. So A and B both must be in the same state. Then try to walk where a surveyor is standing some meter or feet, and again draw a point C, and again walk some feet or meter, suppose the point D, and then from D walk a perpendicular of the river, and in such a way that the point and the second bank of the river, draw a straight line from B, C, and E. Suppose if you reach at the point E, then if these 3 points will be in the straight line, in this way you will get the two right angle triangle. One is ABC and the second is CDE. And with the comparison of these two right angle triangles, we can apply the properties of the similarity of the triangles, and the width is unknown, and here the AC and CD is known, and D is also known. So these three things are known. So in this way, through proportionality theorem, TiL's theorem, we can find the width of the river. So this is a very interesting application of the similarity of the triangles, and you can say that these are the application of the BPT, that is the basic proportionality theorem, and its converse also. Now, we can make the blueprint and floor plan with the similarity of the triangles. Roof and frame construction. These are in the civil engineering. We can use the properties of this similarity of the triangles, making a blueprint of the map and the floor plan. Similarly, the roof and the frame construction. Optics and photography. In the photography, we can use always any photographer, the zoom is a very important. If we have a very in our screen, we can zoom this optics and photography line. We can zoom it. We can see it in the same proportion in zoom mode. and we can minimize it in the same proportion. So in the photography and optics, it's very important. We can enlarge the any object, we can minimize the any object, or we can make some photo films of the same object in a large proportion as well as in the small proportion. So it is the similarity property of the triangles are applicable here in optics and photography. So now here in the case of the triangle, two important theorems, that is the basic proportionality theorem. What does it show? That is, we can, if we have some parallel line in the triangle to the third side, then we can have the two proportional. That is, if D is parallel to BC, then AD ratio DB is equal to AE ratio EC. So with this help, we can show the proportion of between the two sides. And converse of this, if we have the proportion, then we can show the parallel of the D is parallelism of the D to the BC. That either D is parallel to BC or not. So if AD ratio DB is equal to A ratio EC, it shows that D is always parallel to the BC. So these two things are very important. So I can say that in our similarity of the triangles in the 10th grade mathematics, the application of the similarity in our daily life, how we can get the height or distance, unknown height with the help of the similarity in our engineering, in our daily life, like that optics and photography, or in television screen. In the large screen, we can see the news reader in the very proportionate, a big figure. And in our mobile, the proportionate figure is very small, but both are the same shape, not same size. So these are the two similar figures, either on a big screen, either on the small screen. They have the same shape, not the same size. So these are the some things are very important in the case of the triangles. Some challenging areas are also I want to discuss, which are not given in your the boot camp book. That is in the case of the arithmetic progression. There are some the arithmetic mean is a very important. And here the one pattern is about the geometric progression and harmonic progression. Only want to discuss, not is given in the textbook of the 10th grade mathematics, but it is totally associated with the pattern. Now, what is the arithmetic mean? That is, if A, B, C, or if you have the only two numbers A, B, then what is the arithmetic mean? That is A plus B by 2. And if we have the pattern, that is the ratio of the two consecutive terms are same. That is, if we have the A, B, C, D, B by A is equal to C by B is equal to D by C. So this is also pattern, no? Number pattern. And such type of the progression is known as the geometric progression. And if we have some like that terms of the reciprocals are that in AB. That is, if we have the terms 1 by 2, 1 by 3, 1 by 4, and reciprocals of this is 2, 3, 4. So that will be in AP. So that is any type of the pattern known as the harmonic progression. So here only just to give us some idea about that pattern, about the geometric progression and the harmonic progression. And there is a very important relation. Like that, the arithmetic progression is equal to A plus B by 2. If we have the two numbers here. And what is the geometric mean is root of AB. And the harmonic mean is 2AB by A plus.
So the screen is not moving at all.
No, so not it is not given in your PPT. So only just for your knowledge, I am giving you. You can only listen it and can write in your paper. That is, it is not given in the 10th standard mathematics, but it's very useful in our daily life. That is the arithmetic mean, that is the associated with the arithmetic progression, and arithmetic mean of the two numbers a plus a plus b by 2. And the geometric mean is root of ab, and the harmonic mean is 2ab upon a plus b. And there is a relation between these, that is the geometrical mean, square of the geometrical mean is equal to arithmetic mean into the harmonic. And arithmetic mean is always greater than or equal to geometric mean, and geometric mean is always greater than or equal to harmonic. Equality notation is only valid for the same number. If a and b are equal, then equality holds good. But if a, b are different, then always arithmetic mean of ab is always greater than the geometric mean, and geometric mean will be greater than the harmonic. So these are some things, the means are as well as the some progression which have the pattern are also important from the progression point of view. But in our 10th grade mathematics, only the arithmetic progression is given. So other two things are important according to our textbook, the nth term and the sum of the nth term. One thing is very important. If we have the infinite arithmetic progression, like that 1 plus 2 plus 3 plus 4, or like that so many arithmetic progressions, then how we can sum up that infinite arithmetic progression? Here in the textbook only the sum is given for the finite number of the arithmetic progression. But if we have the infinite number of the term, then what will be the result? The result, if the d is greater than 0, if d is increasing, then that will be the some positive infinity. And if the d is less than 0, that if it d is the negative, then we can sum up this arithmetic terms in the minus infinity. So there will be the no definite positive, or either no definite positive or no definite negative. So here we have to only focus for the sum of the finite number of terms of AB. Similarly, in the case of geometrical progression, if d is less than 1, then we can add this. So here we are not going to discuss about the geometric progression or harmonic progression. Only we will get the sum of the some finite number of the terms of the AP, and that is the n by 2 and a plus l. So these are the some things are very important in arithmetic progression. Only geometric progression or geometric mean, harmonic progression or harmonic mean, just only for your the some as a knowledge point of view I was discussing, but not it is the grade 10th mathematics in our NCERT books. As well as in the similar triangles, not only for the triangles, the similarity of the different polygons are very important. We can see that in some monuments like in Taj Mahal or some, if you visit the some temple or some old monuments, then there is some, you can see the similarity of that monuments or some old buildings or some historical objects. There is some very particular two things are very important, the corresponding angles as well as the ratio of the corresponding side. On the two parameter, we can assess the similarity of the polygons. Either it may be the triangle, it may be the any polygon having the n sides. So these are the important things. So here the two units, arithmetic progression as well as the triangles, now it is completed. So you can ask any doubt or any question from your side, one by one.
If anyone has any queries, you can ask right now. I have shared the attendance link on the sheet, on the chat box. You can click on the sheet and mark your attendance. I have shared the attendance sheet on the chat box. I would request everyone to fill the attendance sheet. Is there any additional queries?
Hello, good evening, sir.
Yes, ma'am.
Hello.
Yes, Nita ma'am, please ask.
Yes, sir. Sir, इसकी PPT मिल जाएगी क्या हमें?
Yes. Khalid will, my colleague Khalid will share to you the PPT.
Yes, sir.
But in these two topics, the role of PPT, I will share. He will share the PPT of the both the units of the AP as well as for the similarity. So he will share to you.
Sir,
Sir.
I have one doubt for class 10th basic maths student.
Basic math students only.
Yes, sir.
The syllabus is same for the basic as well as for the advanced, but the varieties of the questions, like that the remembering questions and knowledge based questions, they have the much some more percentage, like that, and for the higher order thinking question, for the application, analyzing, evaluating and creating, the number of questions are less and having the less weight. This is the only the difference. So if you want to like that a question from the similarity, then for the basic students, they can, the paper setter can make the questions like that. What is the, in the MCQ, that is, what are the criteria for the similarity of the triangles? AA, AAA, SS, are like that. Which one is correct? So, but here, the higher order thinking questions are the only for the advanced mathematics. Like that, the paper setter can make, can frame the question like that. If we have the two triangles and they are the congruent, and they are the congruent, is they are similar or not? They are similar or not? The second thing is that if the ratios are given like that 1 by 2, 1 by 4, 1 by 6, and they are similar or not. So such type of the questions, they can assess that either they have the some analyzing property, some analyzing ability or not, some evaluating ability or not. So have you proved the Pythagoras theorem with the help of the similarity. So we can prove the Pythagoras theorem with the help of the similarity. This is for the higher order thinking, for the advanced student. But for the basic, we cannot give the such type of the questions for the 3 marks or for the 5 marks. That is the proof the Pythagoras theorem with the help of similarity. So these are the difference between the basic and advanced systems.
Hello, sir. Excuse me.
Thank you
Yes.
so much, sir.
Hello,
Yes, Prashant ji.
sir. Good evening.
Good evening. Good evening.
Sir, I want to ask. We can use the concepts of class 11 in class 10 if it is comfortable for the students. This is my question. Likewise, sir has compared the arithmetic progression as a function.
It's a arithmetic progression. The arithmetic progression is a function. So that is the only you can say that arithmetic progression is not a function. The sequence can be
Yes.
defined through the function. That is
Yes,
we have the only for the sequence, not the progression. Arithmetic progression is not a function. But the sequence is also the sequence. You can define the sequence through the concept of the function, because we have the domain at the set of the natural number. And suppose if A1, suppose 1 maps to the A1 in the code, 2 maps to the A2, 3 maps to the A3, A5, the 5, A5. So these are the some mapping from the natural number to the code. So only it is for the sequence. And in the higher mathematics, the sequence makes the some functional approach in higher order mathematics. Not in the 11th and 12th, if we want to teach the arithmetic progression, the progression only have the some formula. That the arithmetic progression have the formula, we can generate the pattern through that formula. But in the sequence, it is not necessary. We can make some formula. That is in Fibonacci patterns, we cannot generate a formula. There is no formula. We cannot, but it is a sequence, it is a pattern. So progression is always a sequence, but all the sequence is not a progression. In the class of 11th, we cannot teach the arithmetic progression as a function. Arithmetic progression is a progression, not a function.
Do we have any other queries? If there are no other queries, then let's wind up the session. Is there any other queries?
Hello, Khalid.
Yes, ma'am.
My chat box is not opening, so I'm unable to mark the attendance. What to do?
Okay. So chat box, it's not at all visible. Ma'am, have you
No,
tried?
visible as the chat box is visible. And,
Ma'am, have you
and
tried rejoining?
Okay, I'll do that. Then you share the link again. Just a
Yes,
moment.
yes. I will share the link again. If anyone else is facing the same problem, I would request you to rejoin. Then I will share the link again. Yes. Yes, Ramesh.
So one thing is in the last session, the Khalid ji, please share the PPT corrected.
Sure, sir.
Some typing mistake were there. So please share again that PPT.
Sure, sir. I'll share the updated PPT.
Thank you. Thank you.
Okay. So thank you so much, sir, for today's wonderful session. And Khalid, sir, for completing, can we use the concept? Can we use the concept of class 11 and 12? Sir, actually, I think the Prashant sir was also asking the same question, that can we use the concepts or content from grade 11 or 12 to explain certain concepts or topics from grade 9 and 10, grade 10. Ramesh sir?
In the class of 10th, only the simple arithmetic progression, the concept is given as a pattern, and we can formulate the some general term of that AP. But in the class of 11th and 12th, we cannot teach the such type of the elementary things. And always the arithmetic progression is not a function. Only the sequence is not a function. We can understand the sequence with the with the help of the function concept, because we have the some natural number as a domain, and sequence is from 1 to A1, 2 to A2. That is the correspondence is there. That is why we use the function concept.
Sir, actually, sir's question was also related to the competition. Let it be any topic. Can we use the certain resources from grade 11, which explains the grade 10 concept clearly? Can we
Yes,
use
yes.
that?
As because then AP is also in the JE mains as well as in the advanced, and the series is very important, because through that series here only the simple series is given, that the arithmetic progression, and it makes a series also. But in the so many questions can be made for higher order thinking also, for the geometric as well as the harmonic and relation between these three series. So at the class 10th only, we can develop the formula for the finding the some definite terms of the AP. We can add the some definite number of terms, but in the higher order mathematics, the competition point of view, we can use like that. If we want to make the some infinite number of terms of the AP, we cannot get a some definite sum. So we always get a sum and definite sum, that is the plus infinity or minus infinity. So such type of the questions can be asked in the 11th and 12th also.
Sure. So I think you can also submit resources even if it's from grade 11 and 12, grade 11 and 12. If it clearly explains that specific topic from grade 10, whichever topic that we have listed around 6 to 7 topics for each chapters. If it aligns and if it explains really well, then you can definitely submit it.
And the one question in our chat box, for example, in trigonometry, can we use the unit circle to explain the trigonometrical ratio? Here, it's a good question. When we discuss the introduction to the trigonometry, then I will discuss the what is the unit circle and how we can differentiate between the trigonometrical ratios and trigonometrical functions. So we always use the trigonometrical functions for any number of the angle. But in the trigonometrical ratios, we use the only for the acute angle only. So it's a discussion for the trigonometry, introduction to the trigonometry. So I will
Yes.
discuss it, what is the unit circle and how can we use the unit circle as a trigonometrical function.
Thank you, sir. Thank you.
I think there are no other queries. If there is any other queries, you can ask now. Otherwise, we are winding up the session. Is there any other queries? Okay, I think there are no other queries. So thank you, everyone. Thank you, sir, for the wonderful session. Good night, everyone.
Thank you. Thank you.
We'll be updating the next session. Most probably in the next week it will happen.
Okay.
Thank you.
Thank you. Thank you.